Back here again with the one more video. In the yesterday we did not have a lecture as it was a Sunday, but today we are back here again with the one more new video of our lecture series. On Saturday we had talked about the magnetic properties of the solid, right? Today's lecture we will be doing the problem solving. So in this particular chapter, problems are also asked from this chapter, so we will solve those problems. But before going to the problems, we will have a short revision of the last period, what we had done. Let's come here. So in this case, in the day before yesterday, we had learned about the magnetic properties of solid, right? So what is the magnetic properties of a solid? Magnetic properties of a solid are divided into 5 parts. That is a diamagnetism, paramagnetism, then diamagnetism, paramagnetism, ferromagnetism, then antiferromagnetism, then we had seen the ferrimagnetism, right? So you can see 1, 2, 3, 4, 5. I told you diamagnetics are those which does not contain any kind of a unpaired electron. Paramagnetic, ferrimagnetic, ferromagnetic and antiferromagnetic contains the unpaired electron, right? And this paramagnetic shows a very strong attraction for the magnetic field. It does not show the strong attraction for the magnetic field, right? So this is what we had learned in the last period. Now the question comes, how to calculate the magnetic moment. See, we can calculate the magnetic moment by using this formula. Mu is equals to under root of N plus 2. This is the formula applied for the calculation of the magnetic moment, right? So let's see how to solve this particular problem. Okay, so we'll take one problem. I request all the students to note down the problem. The problem is calculate the magnetic moment of Fe plus 2, right? We have to calculate the magnetic moment of the Fe plus 2. So what is the Fe? Fe has a atomic number of 26. Electronic configuration of Fe: 1s2, 2s2, 1s2, 2s2, 2p6, 3s2, 3p6, 3d6, 4s2, right? As I told you, it has the configuration of a 3d6 and 4s2. Now what will be the configuration for Fe plus 2? Plus 2, 2 electrons will be given out. 2 electrons will be given out means the configuration will be 3d6. Now let's draw the 3d6. 1, 2, 3, 4. So 1, 2, 3, 4, 5 and this is 6. See, it contains a configuration of 3d6. So I am drawing it 6. I am filling it 6 number of electrons in it. So how many number of paired are there? 1 is paired and 4 are unpaired. See, remember, what does the formula says? Mu is equals to under root of N plus 2. This is the formula. N is nothing but the number of unpaired electron. Remember, we are talking about the unpaired electron, not paired electron. So mu is equals to under root of 4 plus 2. So mu is equals to, it will be 4.9 Bohr's magneton. Remember, this particular unit is Bohr's magneton, and this particular question of calculation of the magnetic moment has been asked many a times in your board exam, right? In a section C or in the section D, at least for 1 mark, right? In a sandwich questions they can ask you. Sandwich question means the questions which are coming in your section D, those are the sandwich questions, right? So in that particular thing they can ask you the calculation for the magnetic moment. Actually this particular part is of a D block element. We are going to separately learn about the D block element and how to calculate the magnetic moment in that particular chapter, right? So details we'll see there, but for your understanding, I have told you how to calculate the magnetic moment. Okay, let's move further. Let's go for the other calculations. Okay, I request all the students to note down the problems. So problem number 1. So in the problem number 1, barium has a radius of 224 picometer. Barium has a radius of 224 picometer and it crystallizes in body-centered cubic lattice. Then calculate its edge length of unit cell. Edge length of unit cell. Right? So this is the problem which has been asked. Barium has a radius of 224 picometer. It crystallizes in what? Body-centered cubic lattice. Then calculate its edge length of a unit cell. Now let's see what is given in the problem. First, always remember you are supposed to write down the given. What is given in the problem? So number 1, radius is given 224 picometer. Number 2, what is given? Then it is given, we need to calculate the A. Then what kind of a crystal it is? It is a BCC crystal, right? So this is what is given in the problem. Now let's solve the problem. Let's see. I request all the students to note down it properly, right? So before that, we have to calculate the value of R. Value of R is equals to 3 under root A by 4. This is the value of R. How did we calculate this that day? We had seen the calculation for the radius. You might be remembering it. See, these are our constituent particles, right? Constituent particles at the corners, one in the middle in the body centered, right? So this becomes your body diagonal. Are you able to identify? This is a body diagonal. See, so we can say how many number of radius are present? 1 here, 2 radius here, 1 radius here and 1 radius here. That means 2 plus 1 3 plus 1 4. So 4R is equals to body diagonal. 4R is equals to body diagonal. So 4R is equals to under root of A square plus A square plus A square. 4R is equals to under root of 3A square. 4R is equals to A under root 3. R is equals to A under root 3 by 4. So this is how we calculated the value of radius. Okay, now let's move further. Now we know how to calculate the value of a radius. Now we need to do the calculation. R is equals to 3 into under root A by 4, right? So here we need to calculate the value of A. So A is equals to R into 4 by 3. A is equals to 224 into 4 divided by 3. Then A is equals to, it will be 896. This will be under root 3. Right? So here value of under root 3 will be 1.7320. Value of A will be something 517.3 picometer. Right? I hope that you have understood this. Right? Okay, I hope that you have understood this problem. Okay, let's go for the next problem. Problem number 2. So in the problem number 2, it is a similar kind of a problem. Aluminium has a radius of 125 picometer and it crystallizes in cubic packed crystal. Calculate its edge length of unit cell. Calculate its edge length of a unit cell. Right? So here in this case, again we will write down the given. What is given? Given is radius 125 picometer. Then we need to find out the A, that is the edge length of the unit cell. And then what kind of a crystal it is? It is a cubic packed structure, right? So in this case, we also need to calculate the value of R. What is the R? R will be A 2 root 2. This will be the value of a r in this case, right? So what we will do, a is equals to r into 2 root 2, right? So a is equals to, value of a r is 125 into 2 into under root 2, that is 1.4142. A is equals to, the total value will be something 353